Hi all, we are Ori-Arrow, a cloud and IT services provider. Today we have our group members, Carl, Charlotte, Maeve, and Christina, here to walk you through our project, the Instacart Market Basket Analysis Project. Our presentation is structured in 8 sections. Let's begin with the project background. As an online grocery provider, it is essential for Instacart to realize its customers' personal best in their shopping life since its early days back in 2013. So the company initiated a market basket analysis program needs to gain insights of each customer's behavior to predict what the individual and similar customers they are likely to buy again. Our project, our data crunching solution, SPADA Smart Recommendation Engine, aims to make the online shopping experience more intuitive. Next slide, please. Now let's begin with data description. There are 5 datasets in total, covering 3 million grocery orders from more than 20,000 users. Most of the attributes are either integer or string. In the ER diagram, it is straightforward to see that we can get a full picture of essential data through joining primary and foreign keys among datasets. Next, let's move to our solution design. We are offering 2 solutions, AWS cloud-based and dbt-based solutions. Now, let me start with our first solution, AWS cloud-based solution. The data source CSV files firstly loaded to S3 bucket. From there, it comes to the Glue crawler. We use Glue crawler. It automatically extracts the schema from S3 and updates the Glue schema. Glue offers a data catalog services that facilitate access to the S3 from other services. Once we had the data and the Glue schema in place, we started the data transformation. There are 2 routes. One route is SQL with Athena to query the imported data. The other way is Glue Data Brew in conjunction with Glue Job. Once we get the feature data output from the ETL process, then it loads the output back to the target S3 bucket. As for the automation, we used Event Trigger from AWS Event Bridge to make the process more automatic. Its schedule functionality is used to trigger our Lambda function, start job run. Lambda functions trigger jobs that runs on a daily basis. Also, this could be as per future business requirements. When it comes to machine learning process, we use SageMaker to train and deploy machine learning models in the cloud. We use SageMaker because it is built on the Amazon's rich experience developing real-world machine learning application, including product recommendations, personalization, intelligent shopping, etc. So it is a good match to our project. The same machine learning process is applied in both solutions, which will be deliberated later. So before we deliberate the machine learning process further, now let me hand it over to my group mate Carl for our second solution first. Thank you, Carl.
Thank you, Christina. So let me introduce our second solution, dbt. So the reason we want to use dbt is because we can use Docker Airflow to let the data automatically flow between the snowflakes and S3 buckets. So the result will be shown like the Airflow graph as it shows is a load raw data from the snowflake and will transfer in the dbt. Then we load it back to Snowflake and load it back to Snowflake and then load it back to the S3 buckets. All this process will automatically be done, and that can be controlled to be done daily or monthly, even for 12 hours. This magic will be all finished in a DAG Python file. So in this project, we have 4 models, and we want to carry out as a table, and it can be used in the SageMaker. So we add this code in our model SQL file, and it will directly generate the table and save back in the S3 bucket. And before we running the Airflow, so we just do some test. It's dbt run, and it will, and the result is successfully. We run the comment successfully, and the result is shown in the Snowflake. So before we jump to the DAG Python file, so we have to finish our configuration setup. So which is a Snowflake connection and the AWS connection. We have set up the connection ID, and you have to provide your access key and a secret key for the AWS, and region and account name, and password for the Snowflake connection. So after all things done, so we can jump to the DAX Python file. So as you can see, we have imported many variables, and for the task-wise extracting, so that's as you can see, the code we extract in the S3 bucket from that URL link, and we define the S3 connection ID and the Snowflake connection ID, and we plan to run this daily rather than hourly, because I think the data will be updated in 24 hours. So that can be done in this code. So the task 2 and task 3 is running the transforming and the loading. So for the task 2, we're going to run batch command, and this dbt will find that the specific folder, which is Ori-Arrow, and run the dbt code, and run dbt code. Then the data modeling, the data transfer is finished. Suddenly, the task 3, we haven't managed to finish that part, but that will be shown in our future work. So I think all of this will be running automatically. No one need to touch anything, and I just need to type the Docker compose up. So everything gonna be finished, and the Maeve will directly use the table already processed in the S3 bucket for the machine learning. And the beauty of this this solution is we can have a strong version control. As you can see, for the even this screenshot is happened like 1 month ago, but it can easily to manipulate the version control and share with the different members in our groups. So it can easily to change the Python code, even for the models. If you want to add more models or change any models, it can automatically synchronize remote online, and people can make their contribution to this project. So I will hand over to Maeve. Hello, Maeve?
下一个组员是谁呢？
你有打开你的静音吗？
组员是谁呢？我可以帮他 unmute 一下，如果他自己不方便的话。是
丹梅里。
对，弹幕里已经是 on mute， 但可能是你那边的麦克风有点问题。
Can you hear me?
OK， 现在可以了。
Thank you, Cars. The purpose of our making this data, getting this data from our pipeline, is to make product recommendations for the user. According to this user's purchase behavior, before we make modeling, we have to choose.
妹夫，你声音有点很小，可不可以大一点？
Now it's okay. Can you hear me?
Mf 可以了，你说吧。
就是麦有点问题。
Hello， 这个
现在这个声音可以吧？
可以听到，你继续吧。
So, and before we make modeling, we have to do feature engineering. The main features we need to note is the what products is mostly ordered, and how long is order, and for who. That means for what kind of users to order this product. Firstly, we have to create our table to combine all the order and products, become an order product table, because in this table can have all the features we need. We have to do the feature gathering, firstly get the next order number for each specific user, and we have to note the interval days since the last order. So to note what products mostly order, and we have to do the reorder ratio for each product for each user, and then we have to rank it. So we can take a look at the table on the right of our slides. This is the ranking. We ranking the reorder ratio for all the product for this user. This lead to us to have the conclusion and which product is mostly ordered for this user. Now, finally, we combine all this feature into one single file. We call them data.csv file. We just take a look at the table down below. This has all the features we need. Now, next page, please. Now we are ready. Our data is ready for end user to use. Now the data CSV file has put in the one AWS S3 bucket, the staging bucket. This is for the input data to the AWS SageMaker. AWS SageMaker is working like a machine learning engine. We use, because we implement this machine learning engine, implement this recommendation system by art, we use XGBoost model to do this recommendation. Now, imagine an end user e-commerce shopper click. We can look at the end user. They make a click on grocery. Then they would have a request for AWS API gateway, and this works as our web server. AWS API gateway pass this request from the Lambda, and this is a Python. This is our Python code from Lambda and transfer them to the AWS model endpoint. in terms and transfer back to the SageMaker, then the SageMaker would have a response, but this response is an inference, can carry the inference response back to through AWS endpoint and through the AWS API back to the end user. Recommend when this end user click on grocery, then the recommendation is the egg, or like a cucumber, the supposed order for the last recent months for this end user. This is how the data science model deployment work. Now I pass to my our next member, Tarot.
Okay, thank you, Maeve. Next, I will talk about how our data processing. We choose batching processing, and the frequency of our run pipeline engine is once a day. According to the evaluation of the project, the daily customer buying behaviors and the consideration of cost, we don't think it's necessary to choose the stream processing is a good idea. The business requirement of this project is grocery online ordering. According to the data, each customer's order frequency usually on a weekly basis. If we analyze the data of the same customer and make the recommendations, it's not necessary to reach the frequency of real time. And another important reason is that the cost of using Amazon Kinesis data streaming is very high. Usually, batching is applied to a fixed size finite data, and streaming is applied to an unknown infinite data size. If the data increase significantly later, then we will consider the streaming data solution. Next, please. So in terms of the future work, we have 3 points need to be improved. The first point is the CI/CD. Next step, we would like to realize the full automation and hope that with the cooperation of DevOps, we can achieve full automation of the entire pipeline processing, which can be run in a virtual environment every day. And by the way, here I want to thank you for the DevOps group member Archer. And the second point is streaming. As mentioned before, streaming is more flexible and more adaptable to rapid market change. So if there are any business needs in the future, we can consider streaming tools. The third point is linked to the graphics processing software to automatically send emails. Suppose we can realize what we want. After the processing of the machine learning, we can use the output of the SageMaker to connect to the database of the product's images. Then we can pass the pictures to the graphics processing software and adjust the image to a standard size and format. With searching of the product's name and their price in the database, it can be combined the information and image to generate posters and automatically send the recommendation emails directly to the customer. Next page, please. In conclusion, our business goal is deliver our smart recommendation image, which can help the Instacart app to sort items for customers to buy again and to recommend items while they shopping. The smart recommendation model will be built on its 3 million open transactional data. More than that, our solution helps query data in a rapid, reliable, and efficient manner. We will provide 2 solutions. One is the AWS cloud-based, and another one is the Snowflake plus dbt plus Airflow data pipeline. And we are Ori-Arrow, a data and IT service provider. We are committed to provide an automated, secure, stable, and integrated solution for our clients. Thank you for listening. That's all.